Give
presentation.
me please 10 minutes for
Okay,
presentation.
okay. Sounds good. We have spot for a question for you. It's a good idea.
Okay.
Yeah. Please go ahead.
Do you could hear me? Do you see the screen?
Yeah, we can see full screen. Thanks.
Okay, thank you. Hello everyone, I am pleased to present a paper on siege for the shortest road considering physical obstacles, a method of controlled waterfall, tools and application. Next slide. In the paper, I will give a detailed description of the motivation of the work itself, the tasks, the goals, sets, and the development algorithm based on the rectangle method. I will also present the developed simulator, which shows the mechanism of work. The motivation is the importance of the developing a reliable monitoring system of critical infrastructures. When developing diagnosis systems, the stringent requirements of the system autonomy, response time, and mobility must be taken into account. Diagnosis system based on wire data transmission are a traditional solution, but are highly susceptible to external influences and have long deployment times. However, the use of unnamed mobile systems solved this problem for the following reason. For example, quick assessment of the situation. Also, it's a cost-effective solution and personal safety. However, solving such problems requires the development of a method and algorithm for planning and routing in space with obstacles. That is why the task of developing algorithms for information delivery in conditions of destruction and obstacles is so urgent. In evaluating the problem works, the described approaches to route planning based on delayed triangulation algorithm and Voronoi point generation as priority nodes, siege algorithm of complex dynamic environments, deep learning algorithm, ray tracing algorithm, and Lee wave algorithm we considered. But it was nothing that the analyzed work do not propose approaches to peer-to-peer communication taking into account physical obstacles and the reliability problem of UAVs. Next slide. The main objectives is to define the problem and solution ways to ensure the reliability of peer-to-peer Wi-Fi communication using drone swarm-based data transmission. According to the problem, a rectangle method has already been presented to avoid obstacles by left or right rule, and this paper will focus on the improvement of this method. There are several requirements for the tasks. Obstacles have an arbitrary shape represented by a polygon, and they must be transferred along a broken line, which represent a road. There are restrictions of the distance of reliable data transmission for Wi-Fi airplane transmissions located on the sites. Neighboring transmitters must be located at a distance less the maximum permissible transmission distance, and the reliability of the UAV during the deployment and application period shall be higher than the required reliability. Several assumptions we also made for the problem. Deployment time and algorithm for the UAV at point are not considered. The autonomy margin of the UAV is sufficient to fulfill the tasks, and all UAVs have the same features. The rectangle method and the development improvement for this method were developed under the following requirements. Obstacles is the workspace are static and do not change the position of the time. Points A and B do not change their position over time. A UAV is sufficient to solve the problem, and deployment time and reliability requirements must be met. On this slide, you see the basic algorithm, which is the basic solution to the problem. The rectangle method, the obstacle avoidance algorithm for minimum corner distance, and the controlled waterfall algorithm are improvement parts of this algorithm. Here. Так. The algorithm can be described as follows. First, we try to establish a direct line of sync between A and B. And if this is an obstacle, we use the proposed transfer algorithm. We repeat this chain of steps until the link is established. And the sweep in motion block describes the algorithm for deploying and verifying requirements. On this slide, we see an improvement of the rectangle method. This algorithm, when encountering an obstacle, estimates the obstacle avoidance length to the corner and selects the minimum avoidance value. The algorithm improves the rectangle method of the minimum number of drones on the road and the minimum distance traveled, but does not graduate the most optimal global road. Next slide. The algorithm of the controlled waterfall consists for two steps. The first step is the formation of the path graph. For this purpose, when obstacle is encountered, it is transferred from both sides, and the point of contact with obstacle and the corners of obstacle are stored. Then the graph is explained by coordinates of the corners. This graph is then used in a shortest path finding algorithm such a Dijkstra algorithm, for example. This algorithm is effective for the minimum number of drones on the road and the minimum distance traveled, but it required large computing power. To visualize the process described early, a path simulator application was developed in Python language. The simulator allows to demonstrate the work of algorithm to random disruption of a specified number of obstacles and of specified shape. You can see the structures for the program on this slide. Next slide. And example. In this slide, demonstrates the rectangle method with left and right corner travelers. Green line, it's our road. A green point, it's our UAVs. UAVs, yes. And this slide demonstrates the obstacle avoidance algorithm for minimum distance to a corner. It's example. And this slide demonstrates the control waterfall algorithm where the left shows the graph formation process and the right shows the shortest passage behind the Dijkstra algorithm. A comparative experiment of the presented algorithm was also conducted, where the algorithm of the controlled waterfall showed itself more efficient in relation on the algorithm for the minimum number of drones on the path and the minimum distance traveled. As a result, algorithms that provides reliable communication between Wi-Fi drones has been developed, and improvement to the obtained algorithm has been presented, and quantitative comparison of the efficiently behind the parameter of minimum number of drones and the route and the minimum distance traveled has been made. Also, physical interference factors such as smoke illumination factors to be taken into account during deployment. As a proposed solution, it's suggested to reduce the minimum granted transmission length and to use combined transmission technologies. Thanks for your attention and the opportunity to report. If you have any questions, I will to try coverage it.
Yes, thank you so much, Kirill, for your presentation. We have definitely questions. Dmitry, please go ahead.
Thank you. I have my traditional two questions. First question. Why is the traditional wave algorithm not suitable for solving your problem?
It's a good question. Thank you. Maybe I take example for the. Oh, 1 second. Maybe I have example for differences algorithm. I I see that that questions in a review, and 1 second.
Sorry, I understand, but you have taken to attention this possibility question, this possible question.
Sorry, can I help us closer of this?
Yeah, okay, go ahead.
Dmitry Andreevich, you to talk about traditional algorithm. What does it mean traditional?
About the algorithm.
Yes, we analyze a lot of different algorithms. There are huge number of algorithms for solving of such problem, and we suggested to simple algorithm and compare with known. Hence, it is not guaranteed that these algorithms are the best, but these algorithms are as minimum rational algorithms.
Have you some research in this area?
Yes, we research this area, and main idea here is how we can search minimal distance, considering applied Wi-Fi technology, and contribution and different forms of obstacles. It's the main idea of this task.
Thank you, Vyacheslav Sergeyevich. And my other question. In reality, drones have access to a third dimension. Why don't you take this possibility into account in your algorithm? After all, a drone can rise above an obstacle.
I'm sorry. Will you repeat your questions? I don't understand.
I said about drone can rise above on an obstacle. Drones have access to a third dimension. Why don't you take this possibility into account?
Kirill, a question about 2D or 3D space
yes.
task. Yes, why you talk about two dimension
Only
task?
2 dimensions, not third.
Yes, thank you for the question. Now this work have some general consequence, and to the space realized in some room of infrastructure, some rooms of infrastructure, and this algorithm will be presented in 3D space on the future work.
Yes.
It is planned.
Thank you.
Thank you.
And I could add a few words if possible. We talk about 3D space issue, and the preliminary decision is the following. Approach based on the suggested algorithm to 3D space task will be the following, but 2 stage. Firstly, we analyze 2D space. After that, we analyze 2D space in vertical issue. Hence, in this case, we can use suggested algorithm. Thank you.
May I add as the author of this paper, please?
Yes, Gamer, please. Yeah, comment.
I want to say that this, by starting with 2D obstacle avoidance, we as engineers and researchers can decompose complex navigation problems into smaller, manageable components. This stepwise approach can help tackle more challenging scenarios systematically. And in other words, modeling obstacle avoidance in 2D environments is essential as it serves as a foundational step in the development and testing of autonomous systems and robotics. It enables safe navigation, learning, prototyping, and serves as a building block for tackling more complex 3D environments and real-world challenges. And as for computation, we face computational efficiency. In many cases, 2D models are computationally less demanding than 3D models. They provide a faster and more cost-effective way to develop and test obstacle avoidance algorithms.
Okay, colleagues, any other comments, question to Kirill?
I have a question.
I see Sergey, yeah, please.
I would like to find out what is the tests. What can you say? How you prepare this test? Is this test belong for authors of these investigations, or is are there the library of the similar tests?
Thank you for your questions. Do you talk about tools?
No, I'm talking who formulated the test problem. Personally, your colleague, or you take from the literature these tests? Who prepared the test? Who formulate this problem of test problem?
Can I help?
Will I use
answer?
cow for friend?
Okay, can I help, Kirill?
Yes, please.
Okay, thank you for your question. Absolutely important question. The testing task was formulated by the following way. We describe square from between source of information and crisis center, for example. Yes, the form and the size. The first step. Second one is number and forms and parameters of obstacles. It's we use random mechanism and generate different obstacles between initial point and final point. After that, realize suggested algorithm. Why we use such kind of form of obstacles? Because conclusion is the following: any form of obstacles for task similar application Wi-Fi technology can be based on such approach, because in any case we need use Angular to describe obstacles any form. Hence, it's one of the limitation, but this limitation is not very difficult. It's really limitation which can be used in this task. Hence we have square, we have number and form and parameters, number and form of obstacles. After that, we generate using simulator these obstacles to get a testing case, and using a lot of such cases according with required probability of trustworthiness, we can get a result of simulation.
Mm-hmm. Okay, and generally speaking, the interest to the tests, as for me, must be linking not only how to generate the test problem and to find the optimal solution, a general solution of this problem, and to show it what this solution, the optimal solution of this test. It is proof. It is necessary to prove that these tests have the general form of optimal solution. And in this case, you can prove the conclusions concerning using the different algorithms proposed of you, and compare this algorithm to the test solutions, general optimal solutions. And occurs that in this test, this solution does not present, and it's a problem. I see that it is very interesting and difficult problem, and
thank you. Your question is a fundamental question, yes. But in this case, we talk about minimal way, minimal distance, or minimal number of drones which are needed for this way. Hence, in this case, if you talk about optimal, we need to take into account, for example, cost of drones, reliability issue. It will be next task. Autonomy characteristic as well. Hence, if we take into account all these parameters, of course, not parameters, indicators. Of course, it will be task of multi-criteria optimization. But as the first time, we formulate this task as a task of search minimal distance or minimal number of drones. I think the next steps will be dedicated to formulate it more general task as optimal task. Thank you.
Yes. Very interesting and beautiful problem.
Yes, absolutely. It's a really very interesting in point of view mathematics, and we demonstrate this task our students from first courses, and they said, "Oh, we can apply analytic geometry to formulate and solve this task." I said them, of course, no way ahead.
Thank you.
Thank you.
Okay, Kirill, I guess it's all question.
Thank you for the opportunity.
Yeah.